Okay, so on number 5 here, they're wanting us to find the length of line segment AB in the figure below. So here it is from A to B. They want us to find how far from A to B. Now let's make sure we understand what's going on here. This is 7 down here, at least on mine, whatever number you have. This is 6 right here. This is 2 right here. And they're telling us this is a right angle, this is a right angle, right angle. And this is 11, at least on mine, over there. So how can we use those numbers to find the length from A to B? How are we going to do that? Well, I imagine you're thinking about what I'm thinking about, and that is extending this line right here, straight across. In fact, let's just go all the way like that. Boom. How far would that red line have to be?
Would that be 9?
9.
Yeah, it's got to be, huh? Because this is 7 right there. And that's 2 up there. So yeah, so it's got to be, this has got to be 9. Let me write it better. So it's 2 plus 7 equals 9. All the way like that, isn't it? I don't like those sloppy arrows. Are we good there? That's got to be 2 plus 7. See how we got that? Because that little extra piece is 2 there in the corner. Okay, good, good. Now, I think the most tricky part is probably focusing right here. This is 6, isn't it? From there to there is 6. Double-sided arrows can be helpful. They just make it clear. That's 6. And notice 11 is all the way, isn't it? 11 is all the way from top to bottom. Let's bring the 6 over. From there to there is 6. Sorry, it's not very clear. I don't like that. It's bugging me. Okay, right? Everybody see, I just grabbed the 6 and I just moved it over. Tracking with me, I just moved the 6 right over there. So now, can I find this top part up here?
Yeah.
How am I going to find that top part?
Subtract 6 from 11.
Beautiful. Is everybody seeing that? It's 11 minus 6. It's got to be 5, doesn't it? Let me pause there for a second. Does everybody see that? Because this is 6 right here. So I just moved it over to compare it right next to the 11. This is 11 all the way from top to bottom is 11. The bottom part is 6. So the top part is the whole thing minus the bottom part. It's got to be 5. Now, why am I doing all that? Well, because I'm focusing in. Do you see why I'm doing that? I'm focusing in on this right triangle right here. And I'm like, oh, now I've got this side is 5. I got the bottom is 9. That's why I did all that work to find the bottom is 9. And now I can find this, call it X or call it C, call it Joe, whatever you want to call it. It doesn't matter. Now I can find that AB side. That's what they want me to find is AB. Call it C. It's part of a right triangle. It's the hypotenuse. It's the side across from the right angle in the right triangle. So now I can go, oh, okay, got it. So A squared plus B squared is C squared. I can solve for the C, plug in. So this is the A and the B. This is the A. this is the b, or vice versa. It doesn't really matter, right? So it's 9 squared plus 5 squared on my diagram. So that's 81 plus 25 is c squared. Use your calculator. 106 is c squared. And then you know how to finish it. Root it. C equals whatever the square root of 106 is. I'm getting 10.295. They said 1 decimal point. So, okay. So I'm going to round it right there. So this is a 9. So wherever you cut off your number, if the digit right after that is 5 or more, you got to round that up, huh? So that'll become 10.3. 10.3. So it's 10.3. Let me pause there for a second and recap what just happened, because that was not simple. That was certainly not simple. There's a lot going on there. So one more time, I basically looked at this piece up here and thought, okay, I need to do a right triangle, Pythagorean theorem on that part. So I've got to find the bottom and I got to find the side. So I found the bottom first off by just taking the 7 and adding the 2. This plus this to get the whole bottom, which was 9. And then the way I found this top part is I took the whole thing as 11 and subtracted the bottom part, which I saw over here on the left, and I just moved it over and said, oh, the bottom part is 6. The whole thing is 11. 11 minus 6, the top part must just be 5. So at that point, so that was the trickiest part. Everybody see that? Took the whole 11, the whole right side, minus the bottom part. Again, 11 is the whole right side, and 6 is the bottom part, for my numbers anyway. So the whole right side minus the bottom part gives you the top part. So I found the top part. I had this bottom of the triangle, and then I could do the Pythagorean theorem with those ones. And that's how it works.